Have you ever really stopped to think about the absolute magic that's happening inside the walls of your office or your school? I mean, you've got hundreds, maybe even thousands of computers all chattering away at the same time, sending emails, loading websites, sharing files. It feels like it should just be complete and utter chaos. So how does it all work? Well, that's exactly what we're here to figure out.
Right. That's the big question, isn't it? How do all these signals not just turn into a jumbled, useless mess? The answer, it turns out, is a really fascinating story of evolution, moving from pure chaos to some pretty incredible efficiency. So let's trace that journey.
You know, to really appreciate just how elegant modern networks are, we have to start at the messy beginning. Back in the day, the only goal was just to get computers talking to each other, period. And the first solution was super simple. But, as we're about to see, it was basically a recipe for disaster. Imagine an old-fashioned telephone party line, where you'd pick up the phone and could hear your neighbor's conversation. That's a bus topology in a nutshell. Every single device is hooked up to the very same main cable, the bus. So when one computer wants to talk, it just shouts its message down this shared line, and everyone else connected has to listen in. Simple, right? But what happens when everyone tries to talk at once?
Yeah, that simplicity came at a huge, huge cost. Every single message was blasted to every single computer, which created a ton of unnecessary noise. But even worse, the entire network was one giant single point of failure. If there was one tiny break in that main cable, the whole network went down. And trying to find that one little break, it could take hours. It just wasn't going to work long term.
So the next step in this evolution was to create a central point of connection. This brought us into the era of the hub, which was a device that tried to solve that single cable problem. But in its own way, it just created a new kind of electronic shouting match. A hub is basically just a multi-port repeater. The best way to think about it is like a town crier in an old village. When one computer sends out a message, the hub has no idea who that message is for. So its brilliant solution is to just shout that exact same message out of every single one of its ports. Hear ye, computer A has something to say. It's a little bit better than the bus, sure, but it is still incredibly inefficient. And all of this shouting leads to a massive problem called a collision domain. Because the hub is just repeating everything to everybody, if two computers try to send a message at the exact same time, their signals literally collide on the network and both messages get corrupted. With a hub, the entire network, every single computer plugged into it, is one massive single collision domain. It is a traffic jam just waiting to happen. And here's the real killer. The more devices you add to the network, the more collisions you're going to get. The network just gets slower and slower and slower, until it's barely even usable. Clearly, there had to be a smarter way to do this. And thankfully, there was. Enter the hero of our story, the network switch. Now, this device looks a lot like a hub on the outside, but on the inside? Oh, it's a completely different beast. This is what brings intelligence and finally some order to all the chaos. I mean, the difference here is just night and day. The hub is a dumb town crier. The switch is a smart mailroom sorter. It doesn't shout. It actually reads the address on the package and delivers the message only to the person it's for. This one simple change has massive consequences. It breaks up that one giant collision domain into tiny private ones for each and every port. This not only gets rid of collisions, but it also allows for something called full duplex communication, which just means devices can send and receive data at the same time. A huge speed boost. So that's the big question, right? If the switch isn't just shouting anymore, how in the world does it know where to send everything? How does it build that mailroom directory in the first place? Well, the answer is actually beautifully simple. It learns on the job. Okay, so check this out. When you first plug in a switch, its address table, its brain, is completely empty. It's a total blank slate. But it's a really good listener. The first time a computer sends a message, the switch looks at the source address on that message and makes a quick note. That device is on port 3. It does this for every single incoming message, and pretty soon, it's built a complete map of the entire network. Now, once an address is in its table, any future messages are sent directly. And what if it gets a message for an address it doesn't know yet? Well, just for that one time, it'll act like a hub and send it out to everyone. That makes sure the message gets delivered, all while it just keeps on learning. Now, for any of this to work, the switch needs a totally reliable addressing system. It needs a language it can read to understand who is sending what to whom. And that language is really built on two key parts. First up is the MAC address. Every single network-capable device in the entire world, your phone, your laptop, your smart TV, your printer, has a unique MAC address burned right into its hardware by the manufacturer. You can think of this as its permanent physical postal address. It never, ever changes. This is the address that the switch is reading and storing in its table. But an address isn't very useful all by itself, right? You need to actually attach it to something. So every piece of data that gets sent across a local network is wrapped up in a neat little digital package. This is called an Ethernet frame. This is the piece of mail that the switch is busy sorting. So this is basically what that digital package, the frame, looks like. Just think of it like a real envelope. It's got a destination address, where it's going, and a source address, where it came from. The switch looks at the source to learn, and it looks at the destination to deliver. Simple as that. Inside, you've got the payload. That's the actual message, and a little thing called a CRC, which is basically a quality check to make sure the data didn't get scrambled on its way. Okay, so switches solve the collision problem, and they deliver mail intelligently. That's awesome. But in a big company, you still have a lot of what's called broadcast chatter. Messages meant for everyone in a specific group. So how do you keep all the noise from one department, like say accounting, from bothering everyone over in engineering? The solution here is the virtual LAN, or VLAN, and this is a truly brilliant feature of modern switches. It lets a network admin take one single physical switch and logically chop it up into multiple, separate virtual switches. It's exactly like taking one giant mailroom and putting up virtual walls to create smaller, separate mailrooms for different departments, even though they're all still in the same building. And here's the key takeaway. A broadcast message that gets sent inside the engineering VLAN will only be heard by other members of the engineering VLAN. It will not cross that virtual wall into the accounting VLAN. This dramatically cuts down on unnecessary network traffic, and it provides a huge boost in both security and efficiency. It brings yet another layer of intelligent order to the network. So we've gone from a chaotic party line to a noisy town crier, and finally to an incredibly intelligent mailroom that we can even subdivide into separate, secure departments. The switch is the absolute master of the local network. But that leaves us with one final really interesting question. If a switch handles all the traffic inside the building, what's handling all the mail between all the different buildings and all the different cities and all the different countries that make up the entire internet? Well, that is a story for another explainer.